Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help us out over here. And it also really helps us reach others in need of assistance with these topics. So what we're going to be going over today is differential equations, and we are going to be using the separation of variables method in order to solve the expressions shown on the screen. And this will be the sixth part in our series for the separation of variables. So we have our equation here, our differential equation here of x times y prime is equal to y minus x. And we are given a boundary condition of y of e is equal to 0, where e is that natural exponent, or you can call it Euler's constant. So what we are looking for with all these differential equations, most likely, is that we are looking for what equation of y makes this statement true. So that's what we're going to be solving for. All right, so let's recall that whenever you see the little tick marks on the y here, that is just saying that's dy dx. So we can rewrite this equation as x times dy dx equals y minus x. All right, now let's try to separate these variables out, meaning we want everything with y on the left, everything with x on the right. So let's go through and let's multiply everything through by x. So we're going to end up with dy dx, or divide by x, sorry. So we end up with dy dx with y over x minus 1, which would just be x over x. So let's take dx to the other side. So we end up with dy is equal to y over x dx minus dx. All right, so what do you notice about this expression right here? Well, it is the form that it is currently a homogeneous equation. So when this happens, what we can do is we can use some substitution to make our lives so much easier when solving this type of differential equation. So let's use some substitution over here. So let's set y equal to ux, and that means that u will be equal to y over x. And the derivative of this portion right here, so we would have y is equal to ux, so dy, and we have to use the product rule here, would be u dx plus x du. So let's take this portion right here, and let's plug it in for y in our equation, and then let's take our dy equation over here and plug it in for dy in our original set. So in doing so, we end up with u dx plus x du on my left side is equal to ux over x dx minus dx. Well, this is essentially just going to be u dx plus x du is equal to, well, the x's will cancel, u dx minus dx. And what do you see here? Well, the u dx's are going to disappear from each side. So essentially, let me scroll down here, give self a little bit more room. So essentially what we have here is that we're going to have x du is equal to minus dx from this expression right here. Well, now we can truly separate the variables because it is so much easier now with that substitution taking place. So we'll just take x to the other side. So we have du is equal to minus dx over x. All right, now since we have the variables completely separated, what we can do is we can actually integrate here. Integrate both sides, and we will get u, because du will just become u. And essentially what this is the integration of minus 1 over x dx. Well, this 1 over x, whenever you integrate that, you get the natural log of x. And since it's a minus, we'll get a minus natural log of x. And then we're going to get our integration constant c. Technically, we would get an integration constant on both sides, but since it is a constant, it is just a number, we're just going to throw it on one side of the equation. Typically, it's thrown on with the x side. All right, so now we have completely integrated this. Well, remember we want our equation in terms of y. Well, what is u equal to? Well, u is equal to this portion up here that I wrote earlier of y over x. So let's just substitute in here. So we would have y over x is equal to the natural or minus or negative natural log of x plus your constant. We'll multiply through by x here, and y would be equal to minus x times the natural log of x plus c times x. Well, if we weren't given any boundary conditions, this would be our answer right here. But since we are given boundary conditions and we have a boundary condition of y of e is equal to 0, we can find what this constant is and we can truly find this y equation. So what this is saying here from the boundary condition is that y is equal to 0 when x is equal to your natural exponent of e. So let's go ahead and plug all of that in, and I'm just going to keep scrolling down here. So we would have 0 is equal to minus e natural log of e plus c times e. Well, this is really quite easy because whenever you take the natural log of your natural exponent, this just comes 1. So the natural log of e is always just going to be 1. So essentially what we have here is 0 is equal to minus e times 1 plus c times e. Well, it has to be equal to 0, right? So just looking at this equation, c was going to have to be 1, because if you have minus e plus e, you get 0. So my true equation here is going to be this. Once I plug in my constant, I have minus x times the natural log of x plus 1 times x, which is just x. And that would be my answer for this question. This y of minus x natural log of x plus x satisfies the beginning expression. Well, with all differential equations, well, not all, but most differential equations where you actually solve for the constant, it's usually best to check your answer. And the way you check your answer is we're just going to take this equation of y equals minus x natural log of x plus x, and we're going to plug it into here and see if this expression holds true. If it holds true, then we are good to go. If not, we've done something wrong somewhere. So let's do our check here. And I'm just going to do it on this right side over here. So use a little bit of separation here, and we're going to work our check here. So our answer for our y equation is y equals minus x times the natural log of x plus x. So we have to check that with the expression that was given of x times y prime is equal to y minus x. This is just our given expression. So we're going to plug in y wherever it occurs. And just keep in mind that this is just x times dy dx is equal to y minus x. So let's plug it in here. So we would have x times the derivative of our y equation with respect to x, which is minus x natural log of x plus x, is equal to that same y equation here on the right side of the equation, and then minus off your little x over here. Alrighty, so let's focus on the left side since it's the one that contains the derivative that needs to be taken. Those are usually the harder sides. So we're just going to focus on this side for right now, and we'll come back to the right side here in a little bit. Alrighty, so what we're going to have to do if we're taking the derivative of this portion right here, the minus x natural log of x, what we're going to do is we're going to have to use the product rule. And as I said earlier, you had to use the product rule for the dy in terms of du and x. So this one I'm going to write out a little bit further because it is, well, it's a little bit more complicated, not very complicated, but what we're going to use is we're going to use the product rule for the minus x natural log of x portion. So we are going to set an f variable equal to my minus x, and then we're going to set a g variable equal to the natural log of x. So the dx, or the derivative with respect to x of this portion, then becomes equal to g times the derivative of f with respect to x plus f times the derivative of g with respect to x. And that's just for this portion right here. So let's plug it in. What we got here, where we have g, which is just the natural log of x, times the derivative of f with respect to x. Well, what's the derivative of minus x? Well, that's just minus 1, plus my f, which is just minus x, times the derivative of the natural log of x. Well, we just found the integration of 1 minus 1 over x became the natural log of x. So the derivative of the natural log of x is just 1 over x. So let's simplify this down. We basically have here, we have minus the natural log of x And then we're going to have minus x divided by x, which is just a simple expression of minus natural log of x minus 1. So keep in mind, that is just this portion that I have underlined, the minus x natural log of x. So let's plug that back into our situation here. And what we have here is we're going to have x times the natural log of x minus 1. And then we need to take the derivative of this x right here. Don't forget about that, because that's an easy portion to forget about after doing all of this. Well, the derivative of just a plain old x variable is just plus 1. And that is what I would have on my left side. So let's distribute the x's through. So plus 1 minus 1 is going to cancel. So we just end up with minus x times the natural log of x. That's on my right side, or my left side. What's on my right side? Well, here's my right side right here. What does that boil down to? Well, you have minus x times the natural log of x plus x minus x. So the pluses and minuses will disappear. And what are you left with? You are left with minus x natural log of x on the right side. And what we have on the left side, we just found. Are those equal? Oh yeah, they are. Those are equal. So since the left side and the right side are equal to one another, using this differential equation right here with this y equation, we can truly say that this y equation that we found is the correct one that satisfies that expression. So I hope this video was helpful. And if you want to see more problem solve this right, please check out the other videos on the channel, as we have other differential equation videos up on the channel. And we're going to start doing more differential equations that are not just solved by separation of variables. We're going to start getting into exact first order and second order and more complex differential equations as we go along here. We just need a little bit of time to build up that inventory. So if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel, because all of that does help us out. Thank you for watching, and I hope you have a fantastic day.